Okay, I want to talk about a couple of reactions here, really how we can synthesize alkyl halides from alcohols. There's going to be kind of two parts for this. First, we'll talk about part A, where we're going to be utilizing the SN2 and the SN1 reaction. All right, so let's look at the general reaction. We can take an alcohol, ROH, right? I can treat this with HX. Right? And then we can simply form an alkyl halide from that reaction. All right. The key here is that this can occur via two different type of mechanisms. So this can occur, this can occur via an SN2 reaction and mechanism or an SN1 reaction and mechanism. All right. So let's look at a couple of examples here. Let's start with a primary alcohol. Okay, so if we take a primary alcohol and we treat this with HCl, we can get out a primary alkyl halide. Okay, let's look at the mechanism on how this works, right? So if we have an HCl, that's a strong acid, that gives us an H plus and a Cl minus. All right, so in this mechanism, our chlorine is going to replace our alcohol. So our alcohols are our leaving group. The problem is that alcohols are not good leaving groups. Alcohols are not good leaving groups. And this is a little counterintuitive because we're working with the hydroxide anion all the time, right? Right, we know we can have NaOH, that gives us our OH minus. This acts as a good base, acts as a good nucleophile. But this carbon-oxygen bond is quite strong, right? And it's so strong that a chloride anion, is not strong enough to displace that. So we have to remember in this reaction that alcohols are not good leaving groups. So we need to do something to make it a good leaving group. And that's where the acid comes in, right? So in our first step with our alcohol, we're actually going to protonate that alcohol. Okay, so one of the lone pairs on the oxygen will become a bond to H. So there's only one lone pair left. That oxygen has 5 valence electrons and a positive charge. So now essentially what we've done is made OH2. This is a water molecule that happens to be connected to a carbon, right? A hydronium ion. Okay, this is now a fantastic leaving group, right? This is a great leaving group. If you look at this, this water molecule has no interest in being connected to a carbon anymore, right? So our alcohol is a bad leaving group, but once we protonate this, we now have a water molecule connected to carbon. That's a great leaving group. So now we can undergo our SN2 or SN1 reaction, all right? In this case, if you look at this, this is a primary functional group, okay? We started with a primary alcohol here, all right? That's a primary alcohol. With a primary alcohol, what's favored, SN2 or SN1? Well, the SN2 reaction is favored. So our chlorine is simply going to come in, backside attack that carbon, break that carbon-oxygen bond, right? And then our mechanism is done. So we attack, right? This is really our SN2 reaction, all right? Simple. So here we're doing the reaction, we're forming our alkyl halide, but because we started with a primary alcohol, this is going to be mechanism is going to be happening via an SN2 process, where our chlorine attacks and then forces the alcohol to leave. All right. Let's look at a tertiary alkyl or a tertiary alcohol. Okay, again, we can treat this with HX. Now I'll use HBr. We know we're going to replace that OH with our halogen. But the question is, what mechanism is this? Is this going to be an SN1 or an SN2? Okay. Again, right, we know that alcohols are not good leaving groups. So what do we have to do? Right, we have to protonate this. Right, HBr, strong acid, gives me H plus and a Br minus. How do we make this a good leaving group? Same first step. The lone pair on the O will protonate. Okay, we protonate that. The O had two lone pairs. One lone pair became a bond to H. It only has one lone pair left, therefore that O has a positive charge. And now we've made a great leaving group. Okay, so now we can do our SN2 or SN1 reaction. But what do we know? If we look at this carbon, this was a tertiary alcohol. We have now our hydronium ion, tertiary. What's going to be favored in this case? Okay, so here, this is going to be favored in SN1 process. All right, in SN1 process. So what happens in the SN1 process, right? In the SN2, we form the bond, right? In the SN2, we form the bond which kicks out the leaving group. So our nucleophile attacks, which forces this to leave, right? We have two arrows in one step. In the SN1 process, because this is a good leaving group, the carbon-oxygen bond breaks on its own. We eliminate out that water molecule, okay? And why that's okay and why it works here is we now generate a tertiary carbocation. Okay, a tertiary carbocation is much more stable than a primary carbocation. So this bond can break to form the tertiary carbocation, and then in the next separate step, our bromine can now attack to form our bond, right? This lone pair becomes a new bond here, right? So the bromine had 4 lone pairs, now it only has 3, and it's neutral. All right, the SN2 process, you attack and kick out the leaving group. In the SN1 process, that's separate steps. This leaves, you form your carbocation, and then you attack. Okay, so this is clearly an SN1 process because we can form a tertiary carbocation. All right, so primary is always going to be happening via an SN2 process. Right, our tertiary will always be happening via our SN1 mechanism, right? What about a secondary, right? Secondaries are a little more complex because they can happen via either mechanism, right? So we know the product that we're going to get, right? Our chlorine replaces our alcohol, but this can occur via an SN2 or an SN1 mechanism. And in fact, you're getting the product formed from a little bit of both. You are forming the product via the SN2 and you're forming the product via the SN1. So both mechanisms are occurring at the same time. And I think more likely with the secondary alcohols, the SN2 process probably predominates, right? That probably predominates. So let's just do the mechanism for the SN2 here. That's an H plus, a Cl minus, right? We need to turn this alcohol into a good leaving group, so we protonate. Right, we had 2 lone pairs, now we only 1, we have a plus. So what's the SN1 process? The chlorine will attack and kick out the leaving group all in one step. All right, so that would be the mechanism for the SN2. If it was an SN1, this would leave first, you'd form a carbocation intermediate, then your chlorine would attack. All right. So overall, we see that we can make an alcohol into an alkyl halide via either an SN2 or an SN1. If it's a primary alcohol, it's absolutely going to be SN2. If it's a tertiary alcohol, it's definitely going to be SN1, right? And if you have a secondary alcohol, it can be either, but most likely the SN2 mechanism, it dominates the two.